Okay, the next section we're going to be covering is 4.3, which is dealing with patterns and nonlinear functions. So hopefully by the end of this video, you can say I can identify and represent patterns that describe nonlinear relationships. So first of all, what is the difference between linear and a nonlinear function? So first of all, a linear function is a function whose graph is a non-vertical line or part of a non-vertical line. So we can see three different examples here where we got just a diagonal line, we got dots that are forming lines. So this would be a discrete example, and then we have this example here, which is a horizontal line. All three of those would be examples of linear functions. A nonlinear function is a function whose graph is not a part of a line or not a line. So for instance here we've got something that we call a parabola. This is a graph from a different type of function, and then this is a graph that more than likely came from an absolute value function. Okay, so let's take a look. How do we determine whether they are linear or nonlinear? So the easiest way that we're going to look at today is just by looking at a graph. So here's an example. A worker's wages W in dollars is a function of the number of hours worked. Graph the function shown by the table. Tell whether the function is linear or nonlinear. So we just have to put our hours down on the bottom and our wages on the side and get our scale set. So if I wanted to go 20 here and then 40 and 60 and then no. Let me try that all again. So this is hours. So this is a 2, a 4, a 6, an 8, a 10. Okay. And then along the side I could go a 20, a 40, 60, an 80, and a 100. So I got 2 and a 20, I got 4 and a 40, I've got 6 and a 60, I've got 8 and an 80, I got 10 and a 100. So this here would be an example of a linear function. I'm going to use a term called discrete linear function. Actually, it would be continuous. We could just connect the dots here, but this is a linear function because it forms a line. Okay, next two, if we just took a look at these, why don't you try graphing them quickly on your own, and then we'll take a look at them. So if I were to graph the first one and try to determine whether it's a linear or not, they kind of look linear. However, if you look closely, as the x's go up by 1 on this side, the x's all increase by 1, but these are not increasing by a steady pace or by a constant. So we would say this is a nonlinear. This is nonlinear. Okay, if I look at the next one, I got a 0, -4, I got a 1, 2, I got a 2, 8, and then I've got a 3, 14, which should be up here somewhere. And this one is linear. And the other way to check is just to look at your table. Increases by 6, increases by 6, increases by 6. So the increase is constant. So we'd say that that is a linear function. Why don't you take some time to, oh, never mind. We got to try and write a function for these. So write a rule that represents functions. So I'm writing an equation. So for these, we're going to think of that same idea that we were doing before. We're going to think of a start with at 0 and then an increase by, and see if it's increasing by a constant amount. Okay. So on the first one, if we take a look, it starts at 0. So the value at 0 is 0. and increase by, well, first one here we increase by 1, and then we increase by a 3, and then we increase by a 5, and then we increase by a 7. So I know right now that this is not a linear function, so it's not going to be in the form of y equals something times next plus something. Okay, so we got to think of a little bit beyond that. So next thing I look, is there a relationship between each x and y ordered pair? So is there a relationship between those two, between those two, between those two, between those two, between those two? And if you look closely, we would see that to find the y, you can simply take the x and square it. So this would be our function for the first one. Okay, if you look at the second one, this time we start with a 1. And then if I look at my pattern, I'm increasing by 4, increasing by 4, increasing by 4, increasing by a 4. So this one is linear, and it's increasing by a 4. So our equation would be y equals 1 plus 4x. Okay, that's all I have for this video. So that is a wrap.